According to the Statistics of Indonesia in 2010, Jakarta has 960,07787 population, which is a huge number of population. And now Jakarta is in the 6th largest metropolitan city in the world. You see? And then, because Jakarta is the big city, of course Jakarta has a big problem, a major problem in Jakarta. And we separate problems in Jakarta into two. The first one is the flooding, which is in early years that the flooding causes 29 victims, and you know these numbers, people's refugees. It is according to BNPP data in 2013, and then total material losses is about 33 billion rupiah per day. It's per day, not for along the flooding, but it's per day. It is according to the state government of Jakarta in 2013. And the second problem is about the trash. According to the sanitation department in 2013, that Jakarta produced about 24.773 meter cubic trash per day. So, can you imagine how much trash that Jakarta produce? And between this problem, they are related, which is trash problem is one of the factors that cause flooding in Jakarta. And this is the data according to sanitation department of Jakarta province. And you can see that the number of population in Jakarta, first in 2005 to 2006, it is decreased again, and then it is increasingly in 2010. And then the amount of the trash, can see it is increasing, but now it is reduced. But even it is reducing, it is decreasing, but it is still a huge number for the trash accumulation. And then about 70% trashes are dumped into the Ciliwung River, because Ciliwung River is one of the main river in Jakarta. It is according to the Department of Environment and Environment. And then, what's happening after trashes are dumped into the Ciliwung River? The trash is going to accumulate along the river in Ciliwung. You can see the picture. This is happened because the trash are dumped into the Ciliwung River. And then, because accumulated along the Ciliwung River, it is causing flooding in Jakarta. Now, we're talking about the Ciliwung River. This is the map of the Ciliwung watershed. Ciliwung started from here around Cisarua Bogor in Punjab, due to the coast of Jakarta to Jakarta. And then you can see there are three important weirs in Ciliwung watershed. The first one is Katlabat, the red one here, and the second one is Manggarai Weir. It is located in Jakarta. Now, this is the Katlabat Weir, and this is the Manggarai. You can see the differences between these two weirs, because this is the big one, this is quite smaller than this one. And according to the city government of Bogor, in 2012, there are about 5 tons of garbage were recorded in December 2012. This number of garbage is only recorded in Katlapa Weir, not along the river, but only in Katlapa Weir. And then for the case this one, it's about 70 tons of garbage per day. 70 tons garbage per day are accumulated in Manggarai Weir. It is according to the Jakarta Public Works Department. So you can see the number of garbage. It is very large number. And then according to this problem, it's perfectly that we need an effective solution to solve garbage accumulation along the watershed. And then what we invent is the automatic trash net. Automatic trash net is an effective solution to solve this problem. So what we need to make an automatic trash net? What step that we have to do to invent this automatic trash net? The first one, we have to collecting the data of the Katlabat and Manggarai Weir. What kind of data? The first one, we have to know the dimension of the weir. How long is it? How deep is it? And then how much the flow rate that goes along the weir, and then the discharge of the river, and of course the total garbage accumulation along the Ciliwung River. And then we have to make the engineer design plane of the automatic trash net. Then we have to calculating the potential of the automatic trash net in order to lift up garbage accumulation. And then we have to cooperate, of course, we have to cooperate with the stakeholder and the local society or the weir area. It is of course. And then the last part is we have to constructing this automatic trash net, which means that we have to realize this automatic trash net. So the first step is we have to do the stepping method and measuring step to calculate the dimension of weir. Why we have to use the stepping method? Stepping method is used for measuring the length of the weir, because it is too far away, it's too long, the weir, so there is not enough tape to record how long it is. Then we use the stepping method. And then the measuring step is used for how deep is the weir located, how deep is it. And the second one, we use the current method to know the measure of the flow rate. This is picture of current method. And then we calculate it with the two formulas. The first one is for calculating this term. You can see this Q, C, B, H, which is Q is the start, efficiency, wide and depth. And this is the other one to calculating the potential of the automatic trash net. So, what is automatic trash net system? Automatic trash net system is a garbage transporter which is designed as an automatical toward the mainstream of the weir at several points of the river. You can write it down. And the idea of automatic trash net is like this. The trash that goes along the river is accumulated in one point, and usually it is located in the primary channel of the weir. You can see that in every weir, mostly the weir has the primary channel, which is in primary channel there are a lot of accumulated trash. So the automatic trash net is like an automatic tool that can lift up the accumulated trash into the surface, so that the flows are clear and there should be no more flooding caused by the trash. And then this automatic trash net is very effective, simple, efficient, and cheap. And we already calculating how much that we have to spend to make this automatic trash net, and it is about 325 million rupiah only per unit, and it is cheaper than the existing trash net in Indonesia. Well, actually there is an existing trash net system in Indonesia, but it is about 6 times do this number, so which means that it is really cheaper than the existing automatic trash net. And this is the design of automatic trash net. So you can see this is not the weir, but this is the primary channel of weir. And this is where the trash accumulated. And then this is where we located it, the automatic trash net. Now this is the example of the primary channel weir. So we are gonna put the automatic trash net here, and then the automatic trash net works. It is lift up the trash automatically to the surface, so the water can pass through the primary channel by clear. So this is the dimension of the automatic trash net. Dimension of 2.8, 1.7, 4 square. This is where the exactly located an automatic trash net. It's like a box, a box like this. And then trash gonna go inside this box, and then it is automatically lift up to the surface. Yeah, next. So the Kotlam River accumulated trash in Kotlam River is about 5,000 kilograms per day garbage. And then we already calculate, and it only needs one single operation according to the automatic trash net. And in Manggarai, it's only about 70,000 kilograms per day, so we need about 30 times operation per day. One operation is, so one operation of automatic trash net can lift up about 5,000 kilograms. And what kind of trash that can automatic trash net lift it up? There are 4 kinds of trashes. The first one is the wood, metal, rubber, and plastic. Why only four kind of these trusses? Because automatic truss net decided only three 3 times 5 centimeters. The whole of the automatic truss net only 3 times 5. And what is the benefit of the automatic truss net? For the society, automatic truss net can reducing the amount of accumulated stress in the driver. So which means that if the accumulated kilogram are reduced, it is gonna be no more flooding in the car. And then for constructing the AISCT, the first one for the net that I had already mentioned before, we need to use the galvanized wire with low carbon content. And for the truss detector, unlike for how much that we can lift up, we use the shock pressure transfer sensor. And to lifting up the system, we need this pulley and the hydromechanical. And the level truss are stored in truss dimension that based like I said before. And this is the implementation of AISCT. Of course, we need the supporting stakeholder to implement this automatic truss system. And we need to cooperate with the government state of DKI Jakarta, of course, the Department of Public Works, Bogor City Government, the Department of Environmental and Society. Because these are the stakeholders that related along the watershed of the Ciliwung River. And this is the excellence of the automatic truss net rather than the existing one. You can read one, the first one, it can minimize the accumulation of waste at the Ciliwung watershed. It can minimize the occurrences of floods in Jakarta. It is constructed simply an automatic truss net later in the riverware and utilizing the weir construction to reduce the accumulation of stress, creating an ideal area of Jakarta, and of course that will be Jakarta into an environmental cycle today. And so the conclusion is Ciliwung watershed with its first problem caused flooding in Jakarta. And then automatic truss net is an effective solution in order to reduce the stress accumulated along the watershed, which is one of the main problems that cause flooding in Jakarta. So, flooding in Jakarta, one of the main factors that cause flooding in Jakarta is the accumulation of stress along the watershed of Ciliwung River. An automatic truss system is a solution, an effective solution to solve it. Why? Because the automatic truss net system works automatically. It can lift up about 5,000 kilograms truss, 5 tons, kilograms truss, and the river per one operation. Which means that if there are 70 tons garbage along the river, it can be lifted up only by 30 times operations. And this is our reference. Thank you very much. That's from us. So if you have any questions, give me access. Yes,
is there any question for?
It's okay. Can I ask a question?
Yep.
Okay. My name is Krishna and I'm currently at National Taiwan University of Science and Technology. And there is some question I would like to ask to you. In the earlier slide, you said that in Katulampa that we have 50. I'm sorry, can you show the slide? And then in Manggarai, you said around 70 ton per day, right?
Yeah.
And do you know how they weigh those trash? I mean, if you could say that it's 70 ton per day, do they weigh it every day? Which means they already have a garbage pooling system that could take all the garbage every day, right? And my next question is, in your trash system, you use net, right?
Yeah.
Which means it will reduce the number of water flowing at the same time, because this will have a depth, right? Which means it will reduce the number of, you understand, right?
Yeah, I know.
And then, and you say in Katulampa, the trash will go stuck there.
Yeah.
And one day is one-time operation,
Yeah.
right? Which means it will reduce even further, and will cause the water resistance along the net. And how do you measure if there is a sudden flood, like a very heavy rain, the water velocity is increasing, the volumetric velocity of the trash is increasing. that means the resistance of caused by the water will be increasing. This net will not fail, because if it fails, you just make it worse, right? It's still a moving hammer along the river line.
Yeah, I know what you mean.
Okay, thank you very much.
Can you show a slide of how it Well, actually, I said before that automatic trash net is not located in weir, but it is located in the primary channel. So, can you show that? Next. So, this is the primary channel, not the weir. It is different between weir and primary channel. If until today there are no any kind of automatic trash net that can lift up any trash in the weir, but there is in the primary channel. So there are differences between the weir and the primary channel.
Oh, you mean the data, the trash accumulated is from this part or from the wire?
Do you know what is weir and do you know what is primary channel?
Yes, I mean
it is differences.
The data you got from the trash, the number of trash.
Oh, the number of trash where we got data.
Yes, is it located in here or is it located somewhere else?
Oh, it is located here.
Yeah, that means that the government, the city government, already have a system to take the trash.
But the difference is they lift up the trash by manual, by the human, not by automatically. Because we designed the automatic trash net, it is work automatically. But it is located not in the weir, but in the primary channel. So as we can see, can you show the Manggarai way? Manggarai. Feel this one. Manggarai feel. Where? Yeah. See this one? Yeah. This one is weir. It is really huge. This one called weir. But this one, small one, is called primary channel.
But you said weir also.
But it is also weir.
Oh.
But it is like, you know, different look, like different construction of the buildings. And this Manggarai weir is used only for just to close and open the door. Like for the flow rate to strike it. It is work only to regulate the flow that goes straight to this Manggarai. They only like to open and close, open and close. They work only like that. But for this one, it is different structure. We have like a dropping structure here. Dropping structure. Why we have to make a drop structure here? It is used to reduce the energy of the flow. So, well, actually inside this area, there is some space inside. Like under the water here, there is some space called stilling basin. Stilling basin is like a place that can reduce the energy of the flow rate. So it is the differences between Katulampa and Manggarai. Yeah. So where the automatic trash net work, it is work in the primary channel like Katulampa, like Manggarai. You get my point? Yeah. So that.
What about the fail system? What is the maximum capacity? At some point, it have to open.
Our trash net system.
Yes. Is it have a fail system that can detect whether it's too much or not? Because it's kind of unpredictable.
Yeah. Here we can take a look at this one. The automatic trash net system in one operation can only lift up this number per day. I mean like, those is the verdict. In every single operation, it can lift up about 5,000 kilograms of the implemented threaded. So we already calculate in, can you show the calculation? Let's calculate. So this is the calculation of the automatic potential lift up. So which means that the automatic transnet system only can lift up about these numbers of press in every single operation.
Yes. So do you have any system to measure that? I mean, you don't know whether that day, this is the average.
What I'm trying to say is, when it works, like when it's gonna lift up automatically.
Automatically. So you have a system there that could weigh how many?
Can you show?
Because it's in the water, right? So the
Yeah.
density will be different between when you lift up and
The center. We are using the shock pressure. We are using the shock pressure transfer sensor. It works like this. Can you imagine a box? Imagine a box, and then it is forced by a pressure. That was this sensor works.
That means you're measuring including the water resistance also.
Yeah.
From the water.
Yeah, from the water. So, if there is accumulated stress somewhere here, for example, somewhere here, and then there are pressure by the water.
The water,
Yeah, by the water. So the sensor works that it can detect how many pressure. That until that number before, when it reaches that number, the automatic transfer system automatically lifts up.
So it has a fail system.
Yeah. Yeah. Good.
Okay, I think the time is up, so let's get some applause for this presentation.
Water related disasters in Indonesia. Yeah. Because I think in the last 10-20 years, this water related disasters is quite increasing. Yeah. We recognize it as a natural disasters, but actually it's not quite really natural, because sometimes it is human induced. Yeah. That means if it is human induced, we can make correction. If we can have a better management of the resources. Yeah. So this is our event here, and just click further, giving the title. Yeah. And this is my institution, Department of Geophysics and Meteorology, IPB. So current issues. And actually, I would like to stress later on how science and technology can contribute, yeah, to mitigate and to eliminate this impact, negative impact of the disasters. Yeah. Just go on, because I think this is the outline. Yeah, I would like to stress later on, with science and technology, we can have a better and effective management, yeah, with the disasters. Okay? We can recognize floods, droughts, and forest fires are very common. Actually, like forest fires, sometimes we say it land and forest fires. They are already there for some places like South Sumatra, some part of Indonesia. Not just because of the people are increasing there, yeah, but because of the nature itself. Yeah. During drought season, the fires usually start. But in the last decade, the intensity, the frequency is increasing. Yeah, that's the things that we have to be. Usually, it is related to what we call ENSO phenomena. Yeah, I don't know if everybody is aware of that, but it's getting well known. And the impact is to the economic sector. It's very, very bad, especially during drought. Because during drought in Indonesia, related to El Nino, usually affected like 1 million hectares of paddy field. That reduced up to, in average, 50% of production during that year. Yeah? Therefore, any possible explanation of the science and technology of this cost-effect disasters would be of much value to minimize the negative impacts. Yeah? As I said, it's manageable. If we manage better, we will reduce the effect. Okay? We know Indonesia because most of us are Indonesian except Mr. Yeah, from Vietnam. We have 17,500 islands officially, maybe more. Yeah? Because just north of Jakarta we have 1,000 islands. Yeah? We have 81,000 kilometers long of coastline. Yeah? Maybe more, depends how we determine it. Yeah? We have, according to 2010 census, we have 237 million people. At the present, 2050, we maybe already 250,000. Maybe 250 million, yeah? Because increasing by 1.5%. We have diversities, third in the world, 10% of plants, 12% of mammals, 60% of reptiles, 50% of fish, 70% of birds of the world. Yeah, quite rich. And I would like to stress here, because right now we have Badan Nasional Penanggulangan Bencana, yeah? 7% of these Indonesian disasters are of hydrometeorological types. Yeah, floods, droughts, and the related events. Okay? This is the trend of hydrometeorological disasters. And flood is dominating. Yeah? And we can, until at the present, yeah, the last days I'm living in Indonesia, we still have news about floods in many places in Indonesia, also in Vietnam, Danang area, where it is wrong. Yeah. It's also flood area. Yeah. So this is for Asia Pacific actually. Yeah. Up to the 2010 something. Okay. So we can categorize the disasters according to the causes, natural or man-made. Yeah. And floods we consider it as natural, but actually it's also man-made. Yeah, because with more and more intervention from the human activities, yeah, the floods are more frequent, sometimes more intense. Yeah. Actually, we already know the science behind it. Yeah. We can recognize that pollution. Pollution is very widespread. Yeah. You can see, actually, we can manage pollution. It's very terrible because it affects not only the environment but also the humans. Yeah. And I would say, related to water, pollution becomes a competitor for us to use the resources. Yeah, even worse. Yeah, like for human being, we have enough water just for 100 liters per day per people. But for polluted water, we need 300 liters per kilogram of pollution. And every of us who live in cities, we produce in Jakarta 0.7 kilogram of pollutant waste. Yeah. That means how much water we need to neutralize this pollution. So also our environment, gagal technology, or that's human being. Okay, we just go on. This is all the types with the events, yeah, with the affected. So go on. I think you can have the materials later on if you are in this field. Yeah. This is comparing between countries, Indonesia, and so on. Okay, and this is the record of casualties. We have a very high record here because of the tsunami in 2004. Okay, we just continue with this. This is still some backgrounds. Yeah. Recent conditions of Indonesia hydrological water resources were characterized by occurrence of extreme and flash floods, droughts, and high pollution of water bodies. Okay? And the water crisis is anticipated as a real threat to satisfy the increasing water demand. Okay? And contribution of science and technology to provide alternative solutions are called for and urgently expected. That I think new innovation in science and technology is, and actually we have the science and technology there. Yeah? But the question is how we can implement that science and technology to mitigate the disasters. Yeah? Okay. Actually, we know for the experts who are working in this area, we know the solution. Yeah? So the question is how we can implement it. And one way is through this kind of meeting. So we should distribute this knowledge. We have a good perspective of the problems. So everybody, more people will know it. The solution is there, yeah, including the guidance. Yeah. And this is just the major event. This is a January event, floods in Jakarta. Maybe this is the first time we see this condition. This is Bundaran HI, yeah, center of Jakarta. Yeah. It's flooded for several hours. Yeah. And during that event, all economic activities are down, maybe for 2 weeks. And the economic losses, it's like $2 billion in just 1 week. Yeah. Okay, we can continue. And we have the history actually since the setup of the Jakarta in the 17th century. Yeah, the causes of population increase, land use and cover changes, climate and environmental change. Okay? Population increase in Java, maybe not many people are aware of that one. In the 1800s, the population of Java is only 4 million people. But in 1930, the first census in Indonesia, especially in Java, the number of populations increased by 10 times. So, tenfold population increase in 130 years. But how about right now? With 1.3% growth rate, it doubled in 40 years. That means the census in 2010 in Jakarta, in Indonesia, 237 million. In 40 years, it will become 500 million. If the same rate. Yeah, that's why I think with the case of census 2010, our government is getting alert, yeah, then we have to reduce the rate. Yeah. Otherwise we will have more problem with providing rice and all the related resources. Okay, we just continue. But one thing that are not really known by most of us, even the population is very high and including the density, but actually it is very diverse. In some areas, most of the areas, actually the density is very low, below 100% per square kilometer. Yeah? But in some areas, like in urban areas, the density is very high, even more than 100,000 people per square kilometer. Yeah? But that's the way it is. Like in Japan, with 130 million people, 70% of their people are in 3 urban areas: Tokyo, Osaka, and Nagoya. 70% concentrated in less than maybe about 20% of the area. 70% of the area are forested. Yeah? I think that should be the model of our development in Indonesia. Yeah? We should concentrate the people in urban area, but for that we have to provide welfare and livelihood. Yeah? So that's why I think we need to understand this development so we can develop the policy, development policy that go through that way, including you who are studying here in Taiwan. You can see how Taiwan is developed, yeah? Including this diversity of the population. Okay, we just continue. So until now, it's happening. This diverse foreigners. Yeah. So this increase of population has severely affected the land uses and continuous changes in vegetation cover, with consequences in changes in hydro regimes and environmental qualities. Yeah. Like we know Jabodetabek area, this is Greater Jakarta area. Right now, more than 90% are already urbanized. In hydrology terms, we know that the measure is very simple, what we call runoff coefficient. Runoff coefficient is just a ratio between how much rain is discharged into runoff. Yeah? So if it is still natural forested, the value of this runoff coefficient is 0.001. That means if there is a 1 millimeter, 1,000 millimeter of rain, only 1 millimeter is flowing on the surface. Yeah. But at present, with more than 90% urbanized, the runoff coefficient is 0.9. Can you imagine that? Yeah. That means if the same kind of rain 1,000 millimeters happen in one day, 900 millimeter will flow on the surface, causing big floods. Yeah, that's why even we recognize it as a natural event, it's human induced. Yeah. Okay, we just go on. So this is population increase in Java. At present, it's about 150 million in 2010. Just go on. Land use changes. We just also, as I illustrated, the change of land cover and changes. It causes change in hydrological regimes. Yeah. So what I would say is anthropogenic influences. Yeah. That means we can manage it to mitigate the disasters and also to have a better system. Yeah. As we are landing in Taoyuan airport here, we can see that in Taiwan they already developed this pond system. You can notice, and around the pond they developed this green belt. Yeah. So they have these water resources for their uses. Yeah. But also actually to manage the environment. But that's not happening in Indonesia, especially in urbanized areas like Jakarta. Yeah. All the natural ponds or all small lakes are disappearing. It's aggravating the disaster. Yeah. The flood. Yeah. That's why we need to correct that one. Okay, we just continue. And this is the illustration of the condition of Java landscape outside urban area. This is actually Serayu River Basin. Yeah. The vegetation is gone. Yeah. Because the forest was cut. At the present, the natural forest is already less than 4% of Java. Yeah. Also, outside Java, we will go on. With this kind of condition, the natural soil on the surface is already degraded. The productivity is getting low, yeah, because it's already going to the what we call the bahan induk, the parent material that's on the surface already. Yeah. I hope it's clear enough because the light from the window, yeah. And actually the next picture showing the same area But comparing between wet season and dry season, yeah, it is true that during the wet season it's relatively green, but actually we can see from the parent material of the soil, yeah, it's already low productivity. We just go on quickly. So with that event, we have increased the critical length. Right now, everywhere we go to the districts, in not only in Java, also in other part of Indonesia, 25% of the area are critical. Yeah, you can see the increase of this one. Yeah, population density. This is the average. Yeah? And the character of this critical land is, with this increasing of critical land, more poor people there. Yeah, that's why we call pockets of poor people are usually inhabiting the critical lands. That's why they are trapped in their poverty. Yeah. Okay, we just go on. Yeah. This is the statistics about this critical land. Actually, if you go to the offices, local offices, you get these numbers. Yeah. And you know these numbers, you can plan how much money you have to invest to improve or to rehabilitate the critical land. Yeah. Actually, we know all about this one. Okay, we just go on. And also impact of ENSO and climate change, because in the last 20 years or 30 years, the awareness about this climate change is increasing. Actually, the knowledge already developed since many years. Yeah? But the definition of the climate change is changing also. Yeah? Depends on what purpose. Yeah? So we can have definition according to the, even from the same UN agencies, either from IPCC, it's more scientific based, or UNFCCC, it's more political. Yeah? So the typical rice crop affected by flood can reach 200,000 hectares during the flood event, the La Nina years, yeah, which is 3 times the average condition, with 30% of complete failed harvest. Yeah. But during drought, it's more than that. As I said, during drought, related to El Nino event, the affected area is like 1 million hectares. This is only 200,000 hectares. Yeah. Okay. This is the global impact of El Nino, and Indonesia is quite affected, causing drought. Yeah, in this region. But in some area, especially in Central America, they cause flood during the same event, and so like El Nino. Yeah? It can cause dry effect there or wet effect. Okay. This is the record in Indonesia in the last 100 years. Yeah. The El Nino is increasing. Actually, we identify like 25 El Nino event during that 100 years, the last 100 years, and 16 event in. Okay, but in the last decades, the frequency is increasing. Yeah. This is the flood risk map of Indonesia by district, kabupaten. Yeah. And actually, we have record up to the economic losses. Yeah. Okay, we just continue. And this is the summary of this flood by province. We have the total flood area and the category. Yeah. The category according to criteria from public health. Yeah. Okay. Continue. This is the continuation of the next, the previous slide, and this is the affected to the paddy field. Yeah. As I said, the flood. This I identified only the flood one. It's affected like 20% during the La Nina event. Yeah. 20% of the paddy area. Okay. This is for drought. It's more more extensive. Okay? And how science and technology can contribute. Yeah? Because basically science is trying to identify the root of the problems. Yeah? So if we can use science and technology, we can have more effective decision of the problems, solve the problems. So we see the vulnerable sectors is water resources in general, especially in agriculture, in production system, yeah, especially food production system, coastal and fisheries and marine infrastructures, and health. Yeah. And to meet the scientific principles and needs, basically with science and technology, we can identify, we can formulate the optimality and sufficiency. I think the key with science. Yeah? And science and technology infrastructures. Yeah? We can design better, like you can see the structures in Taiwan, they are prepared for typhoon and also for earthquake, especially in this area. So you can see the building is quite sturdy. Yeah? We can compare with the buildings in our country. Yeah? So we have to build better infrastructure. Yeah? Okay, scientific principles on disaster management. You see, optimality and sufficiency condition. Yeah? For us who are studying in physical sciences, physical insight is very important. That's why we learn physics from primary school, yeah, and up to universities. Even in our research, yeah, we are still improving our understanding about the physical insights of what's really happening. Yeah. So basically, we develop the concept and model on disaster events. We parameterize, and the key in science approach is quantification of event of phenomena, yeah, including in disasters, quantification of threat, yeah, quantification of threat. That's why we introduce these measures like indexes and so on. Yeah. Like for earthquake, we have Richter scale. Yeah. But in Japan, they don't use Richter scale. They just introduce the scale from 1 to 7. Yeah. Like the Fukushima disaster is already at level 7, because at level 7 of the earthquake, you only can lay down on the ground. You cannot stand up. Yeah, you cannot stand up. That's the level of scale. Yeah, that's the way to quantify the threat, and that's the science. Yeah, we have to develop the measure system, and then with this science development, we develop the prediction system. Yeah, we develop the prediction system, satisfying the optimality and sufficiency condition. We use the prediction system in early warning system. That's why we can forecast what will happen if these conditions are occur. Yeah. Okay. We can assess the risk, and further we can use the information for insurance system. Yeah. And a lot of paradox in this event, because the higher risk is faced by poorer people who cannot pay insurance. That's why that's the way of the government. The government has to consider this. Yeah. Okay, we just continue with science and technology infrastructure. I still use the Indonesian. I'm sorry about Vietnamese friend. Terdapat peluang iptex dalam mencegah dan mengurangi risiko bencana. Basically to build the gap between supply and demand. Yeah. You see, with science and technology, actually we are establishing theory, yeah, principles. But in practice, that's according to the policy of the government. Yeah. If it is not based on science, so there is a discrepancy between theory and practice. That's why the success of contribution of science and technology is how we minimize the gap between theory and practice. That means between scientific contribution and practice. Policy, government policy, public policy. Yeah. Okay, we just continue. So if tax pembangunan infrastructure, including part of the infrastructure is knowledge exchange through this kind of meeting. Yeah? We just go on as closing remarks. First, we should recognize that Indonesia is blessed with rich natural resources, as I indicated in that one slide. Yeah? But also not free from many disasters that need to be managed wisely using suitable science and technology. Then, the root causes of this can be traced back to the human intervention, because of the human density that generate land use changes and pollution and environmental degradation. And water-related disasters, such as flood, landslide, drought, and forest fires, constitute a major ones with increasing trends that need urgent solution. Yeah? And science and technology certainly can provide much to solve these disaster problems. Firstly, through the identification of optimality and sufficiency conditions, and secondly, if possible, with enough support of scientific infrastructures. Yeah? Like for floods, the first principle that we should satisfy is conservation of mass. Yeah? Solving the Jakarta problems will go nowhere if we don't follow that one. Yeah? It's very simple. Very simple. As a contribution of science, just satisfy the conservation, the mass conservation law. Yeah? And then we can develop the infrastructure that's optimized. Yeah? Satisfying the optimality condition. I think that's the closing. Thank you. And welcome to
So, we're going to have a question and answer session. So, if there are any questions from the audience, please go.
Thank you very much. My name is Herbie Setiawan. I'm from Bogor Agricultural University, Department of Civil and Environmental Engineering. Well, you mentioned before about the human-man disaster before. Now, what I'm trying to say is, do we have to invent some, like what, a friendly technology to solve the problem, or do we have to remanage the management of the technology that we have now? You got the point?
Yeah, basically, with technology, the purpose of technology is how it gives purpose to human needs. Yeah. Yeah, I think at the present we try, not only we try, we already develop what we recognize as green technology, yeah, or environmental friendly technology. It's become a common term, especially like in the profession. Yeah. Yeah, I think we should go for that.
How about the management of the existing technology?
Because with environmentally friendly technology, basically we are widening the criteria of accepted or acceptable technology. We are widening. Before, we are more narrow. Yeah? With classical technology approach, we are certifying only technical aspects, or maybe up to economic aspects. Yeah? If our design is economist and technologically feasible. But at present, we also have to satisfy the environmental criteria and also the social and maybe cultural. Because like in China, they are developing three-gorge dam for many decades. Yeah? They already designed that maybe for the last 100 years to manage the flood from the Yangtze River. Yeah? And when they implemented it since the 60s, yeah, they are destroying many historic artifacts. That means they don't care about cultural history, yeah, or social. Including Indonesia, when we develop the big dams like in Jeratim Solna and the Gajah Mungkur dam, yeah, we are inundating this many villages. And that in quote, we don't care about the protest from the people. But with the present design, we cannot do that. Yeah? We have to consider the social aspects, including the cultural, and also, as the main criteria now is environmental aspects should be secure. That means should be sustainable. Yeah, our design should be sustainable. So we are just broadening the criteria of design, infrastructural design. Yeah, that's part of the optimality as continuation. But it's just a continuation of our understanding about nature. Yeah. That's why sometimes, once we decided that previous design is not acceptable, we destroy it. We replace it with new one. Yeah? Because it is human being. It's no problem. Yeah? If we consider it is not acceptable anymore, we just replace it with the new ones. But if we consider it still have values to the future, we still can keep it. But that's part of the concept we develop, the human values, yeah? Human dimensions. Yeah? So it's not something static. Maybe in the next time, the next era, yeah, our consideration change. We consider that what we think the best now is obsolete. We have to change. Yeah? And that becomes reality. Yeah. Okay?
Yeah, okay. I want one more question.
Okay.
Sir, my name is Afil. I'm come from Bogor Agricultural University. I want to ask. We've been here for 2 days, and we're so amazed with how beautiful Taiwan is. And along this trip, I saw so many green space in Taiwan. You said that developed country, Taiwan. And I want to ask you, how come if we make Jakarta same as Taiwan and ask for the government and the people there to work together, keep the green space? How about that?
Not only Jakarta, but first Java and then Indonesia. And why we are still having this problem here with everyone, like in Indonesia, I don't know, in Vietnam. And why in Taiwan, they are already reaching this level. They are more developed, we would say. Yeah? Because their population growth is already zero or even close to negative, or close to zero, just a little below zero. That's why their problem is how to keep the population. Taiwan. Yeah. That's why they are not really need development. But what they need is improvement. So what you see, the development here is destroying the old infrastructures that's not acceptable anymore and build the new one which is better, satisfying the present condition, the present requirement. Yeah? Including the highways, the buildings, and so on. They are destroying the old ones and building the new one better according to present criteria. But as I said, in 100 years, maybe we have a new criteria for optimality. We will destroy it. But in the case of Indonesia, we are still developing even the population. Yeah? So actually, in the last census, 2010, so that means the last 10 years, 2010, actually we, in the population aspect, yeah, we are shocked because the expectation, our growth rate is already reduced to close to 1%. But because in the census of 2000, population census 2000, our growth rate is 1.3. But when we got the result, the population growth is 1.49. Yeah? In these last 10 years development. That's why we are still stressed by many population related issues. Yeah? And we need to be aware of that. Yeah? We need to know the present condition, and we need to know where we are going to, especially in implementing this science and technology. Yeah? Because if we are not considering this, maybe what we develop now is giving negative impacts in the future. Yeah? I hope that's I think we should develop the discussion.
Yeah.
Okay.
Okay, one more question. Thank you.
Thank you, sir. My name is Angga. I'm from the Department of Civil and Environmental Engineering, Bogor University. And my question, on January 2013, Department of National Management Disaster, Badan Nasional Penanggulangan Bencana, ever did weather modification engineering. Itu modifikasi cuaca. And my question, what the effect the technology to Jakarta society and around it, and benefit or disbenefit, and what is the effect what is the effective to reduce flooding in Jakarta?
Okay. Actually, I'm not involved with this weather modification technology. Yeah. But I know the story, the history, since the initiations of that unit at BPPT. Yeah. And in the case of last event, actually one of the purpose is to show to the population, the community, that the government is doing something. And actually, the operation for that event in January, yeah, starting from mid-January, maybe 10 days or even 1 month, yeah, it costs for the operations like 20 million, 20 billion rupiah. 20 billion rupiah. Yeah. And maybe 50% of the cost is go to the operation flying the flight. Yeah. And actually in terms of technology, weather modification is we recognize as an effective way either to increase rainfall or to reduce. To reduce, that means reduce in one area and switch to other area. That means in the case of Jakarta floods, we drop the rain to the sea before going, because like in Jakarta there's orographic rainfall. Yeah? So before coming to the land, we drop at the sea. That's the theory behind it. Yeah, the idea. But BPPT already implemented not only in Jakarta last few months in January 2013, but also in Semarang area. They already practice that. Also in other places. Yeah. So, but one of the purposes is to show to the community that the government is doing something and spending only 20 billion rupiah compared to the loss of 2 billion US dollars. Yeah. Okay. All the questioners are coming from Bogor Agricultural University. I'm happy for that. But I think we are also, this is, I said, this is part of the science and technology infrastructure, this kind of meeting. Yeah. That's why we need to keep, later on we do it in Danang. Yeah. We can do that in Danang and have a knowledge exchange between community, scientific community in this area, or also in Indonesia we can do that. Then the community, you can report, oh, we can do the same thing in Indonesia, in MITI. I met some MITI delegates this morning in the bus. Yeah. I think we should offer to the community that not only we do it in Taiwan, but also in Indonesia, in Vietnam, or in other areas. But you can see, you learn something by visiting the country. Yeah, not only from the meeting. Yeah. So we learn from our experience. Okay, thank you.
I think for the question, time's up. So let us give applause for Mr. Dian.
Good morning, everyone. Thanks for the chance as I mentioned. If all of you all would like to present our idea. As we know that Indonesia is one of the countries that often flooded disaster. The remaining conditions in Indonesia as well as the flood and disaster
but also many the people die because of the disaster, and the farmer in the village like to prepare their livestock, then save their life.
Yes, and this one also is a primary job for indigenous people. So they prefer to take care of the livestock first, then to take care of themselves. Like this. So based on the curriculum, we treat the SARS system of animals as true. Let's introduce ourselves. My name is Leti.
My name is Leti.
We are from Veterinary Medicine Faculty of Erlangga University, Surabaya, Indonesia. SARS, System of Animal Rescue, is the innovation of system evacuation and rehabilitation for livestock to be victims of disaster, from before disaster, when disaster, and after disaster.
There are two main things in the system. The first is the livestock rescue. What is livestock rescue? Livestock rescue is the main resources in the system. There are three kinds the jobs of the livestock rescue. The first is the before disaster, and then the when disaster, and the after disaster.
Okay, the before disaster, we must build the team that the team will make the data about the area of the disaster and amount of the livestock, etc.
And then when disaster, the livestock rescue should take care of the animals, and then we increase the example of the total disaster when the Badan Nasional Penanggulangan Bencana announced the status siaga for the areas, and then the livestock rescue should take the animals in the area and then should bring the animals to the shelter.
And then after disaster, the animals will come to the area of the disaster.
And then the second step is we make coordination with the stakeholder, such as the veterinarian, and then the farmer, the community of disaster, and then the meteorology, climatology dan geofisika, and then the Badan Nasional Penanggulangan Bencana.
And then the last is about SOP. It's the procedural or standard in our system. So we have the step or target we will get for our system.
And then in this SOP, it is about the rules of the system and the job description of each part that in this system.
And this is the conclusion of our system is we hope that SARS can make real the technology of the farmers and the disaster to better innovation management of disaster. Better management disaster for better innovation. So thank you. It's our presentation. Thanks all for the attention. Maybe any questions?
Okay, any question for presentation? Maybe I'll ask something. Is there any empirical data for life rescue for animal success in some area? I mean, maybe in some area you can get a research for this procedural step. Is there any area that you conduct some research? got my point.
Okay, maybe we can put in the paragraph. The website will keep the safety it's easy for collecting data, and we must know what is the shelter and the best place for the website for the take care and the fit for the spot, etc. So after the data is finished, they can complete with the thing.
Yes, actually, this is done by the developer in the data, but it's not explicit because there's no coordination with
Our minister tadi, I did it. I think some 1%. Actually, this is the standard recording procedure. Yes, maybe you can explain again. Yes. AISCT.
Okay, the first, we must build a team. Build a team that are the team that there are large companies too. It's the team that will take care of the animals after before and when the disaster, and then the coordination, and then we have the standard operational procedure for them, for their each job description like this. For example, maybe for lobster rescue, the first is they must collect the data for the livestock. It's maybe the amount and the case, and then for the feed, for the what is it, the potential of the area disaster, and then where the best shelter that we can take care of the
I think it's
On Bogor University, in India. What is the advice? This idea with the existing idea. So, SARS introduce rescue animal. Operates of your idea with the existing idea to rescue of animal.
what's new in your idea?
Comparative between the existing idea with your idea
And
what
compare
is
with
your-
previous
yes,
research.
what is your average of your idea? The average.
And difference.
I'd like to answer the explanation. Maybe for the coordination.
Coordination.
The coordination between veterinarians, the doctors of animals, and then BMKG, Veterinary Criminality Indonesia, and then the community of disaster in this area, maybe the animal shelters like this, and then the farmers, and then TPM, basically, the national government agencies. Coordinator for there is not good enough.
usually the animal owners that save the livestock. Maybe if they do after the disaster, so it's not efficient.
Okay. I think it's and the times is up, so
We go over the questions.
Good morning, ladies and gentlemen. Honorable kids and distinguished all participants of annual International Student Conference 2015. At this moment, I'd like to deliver my presentation about identification of landslide potential area at Srimulia Village, Piungan District, Bantul Regency, Yogyakarta by using deployable array theoretical resistivity methods. Me as Muhammad Si Aritama, and then our team from Universitas Gajah Mada. Okay, let's talking about the background of the mass movement, include the landslide. Landslide is one of the mass movement. So, yeah, this is landslide, and landslide is a theoretical phenomenon that include which is in the large, the wide ground motions here, and becoming rock fails, and then a failure slope, and becoming a slow debris flows. And we know that the landslide becoming dangerous if it has any population here, any people stays here. And then the landslide can occur in some places, such as offshore, such as in the coastal and the onshore environment, and becoming the common problem in the world, especially in Indonesia. So this is the example. This is the model of three-dimensional example. We have a main parameters here. We're talking about the gravitational force. We're talking about particular motion. We know the shear strength. We have a component gravitational force. This is the angle of repose. This is the slip surface. So if they have a more increasing of a slip surface and this gravitational force, it's possible becoming a free mass movement. Okay. So this is the particle motion. So we have any parameters. We know that this is the sand. It can be clay, can be wet clay, can be pressure, and all of the particle motion. This is the internal friction between the frames. And so we have many mass movement parameters here. So this is the landslide Indonesia. First, Indonesia is one of the most prone countries to kilometer outside the world. Volcanic eruption occurs especially in the landslide. The second, developing country need more space for infrastructure, industries, and resource and settlement. The third, there were 199 landslide occurrences in 2010, killed 470 people. This data reported from Center to Technology Geological Hazard Mitigation. Yeah, let's talking about the data. We have from the CDGM, and this is the left side. Look at that. The number of landslide events in Indonesia between 2005 until 2010. So this is increasing exponentially by time. This is the time versus the number of victims. This is time against victims. So 2005, look at that, 51 number of events, and becoming increasing until 2010, probably 199. It's different on the right side. Look at that, the number of landslide victims. This is landslide events. 2005 until 2010. So we have the since like random data. So look at the 2009, we have the highest to 659, and it's 2008, and it's 88. This is the landslide event in Indonesia from Indonesian map. We have a frequency number of events. So look at that. We have 5 colors here to identify the colors. So the first one under 16 identify that main level of the prone area of the landslide. So Yogyakarta here, green and between green and blue. So all Indonesian map, we know that it's Sumatra, Kalimantan, Sulawesi, Papua. So it's a cancer prone of landslide event in Asia. Yeah, talking about the location of landslide by geographic map. This is based on our scope research. So look at, we have 3 colors here. We have a dark white, pink. This is what we are looking at by research. In Srimulia Village, Piungan District, Bantul Regency. That located for about 428 and 435 above sea level. So it has a great slope
fairly slope, and for more than 30 degrees of slope. So it's very dangerous having a drone landslide sensor management. So look at that. This is the landslide location of scope of our research. This is Remulio and Bundle. It's all Bundle. B1 Bundle. This is our first trajectory of our research. First line and second line. We have near or north-south direction of propagation. Line 1 for about 100 meters. Stellar here. Line 2 is west direction of propagation, and we have a 100 meters length of measurement. So it is the populations here, the people stays here, and it have more than 30 degrees of slope. So it have a heavy rain is becoming a danger for the people here because it's possible becoming a disaster management, disaster landslide. So as we're talking about the methods and practice of the people geoelectrical methods. From all of these factors here, so the government has decided that the problem of landslide as a national problem that has to be solved, especially in the prone area. So this is our idea, methods in practice to solve this problem with the typical geoelectrical. So geoelectrical aims to identify, to define the subsurface area layers based on various resistivity rock. So we have more parameters here. First, the length of measurement for about 100 meters, and we have a current resistivity is a potential resistivity. We have a space here. So this is the depth. If we current and the potential material maximum spacing, we have a maximum depth. So this is the depth equation. Okay. So this is the typical geoelectrical methods. Let's talking about the resistivity range of rock in our research, our result of research. So the color blue, green, yellow right here, we have a resistivity. The clay in here, 3.12 and 8.12 the clay, and this is the slate surface space here between the bedrock and the moving plane here. So this is the wet clay. Let's talking about the circulation of line 1 in our research. Talking about this north-south direction for about 100 meters sometimes can reach for 70 meters of depth. So look at that. This is the slate surface here, and with 5 until 12 meters of depth here. So this is located for about 428 above levels. The accumulation waters here. Slate surface is located between the bedrock and the moving plane. And results of the surfaces for about 21.5 to 1.3 ohm meters for resistivity range. This is the intersection of line 2. We have a west-east direction. We have a 100 meters line pressure, and this is the slate surface, and it becoming dangerous. We have a more heavy range here. This is the depth of the slate surface from 5 until 12 meters of depth, and reach above this data reach for about 70 meters. This is the inverse of model resistivity section. And the result of the slate surface model is becoming 25 and 26 ohm meters resistivity. Okay, that's the conclusion of our paper here. From the two lines are detected by lithology in the of the clay stone, red clay, cellulose. This is clay, wet clay, and becoming a bedrock and a moving plane. So it's becoming a rotational landslide. Yeah. Then semi-clay rock and centrifugal. So this is where this rock could be potential being a trigger of landslides, becoming the water accumulation in there. This is the conclusion of the three-dimensional model sample. So this is one block. This is the rotational landslide surface of fracture. Thank you for your attention.
So is there any questions for Mr. Nolan? No questions? Maybe I'll try to answer to Anderson. Actually, this method is quite simple in theory. But in your previous research, you conducted in family, and have you ever tried to maybe propose to maybe to the government there in the area, or have you ever been proposed?
This area has been researched by geographic. This is the geographic map, and I have been shown that. So the geophysics of the methods have proposed to solve this problem. So I think it is possible, but can solve the problem in the prone area.
Oh,
Yeah.
so any other question from other person? Or okay, I think it's enough. Okay,
Thank you very much.
give for applause.